Hi, this is Dr. Wendy Rocks, and I want to talk to you today about a really interesting earthquake that happened 10 years ago. This was the Mineral, Virginia earthquake. It was a magnitude 5.8 that happened at 1:51 p.m. local time. It was just northwest of Richmond, Virginia, in a little town called Mineral. So you can see that location. It's the little orange star is showing the epicenter, or the place on the surface of the earth directly above where the earthquake began. Earthquakes start deep inside the earth at a place called the hypocenter. So earthquakes in this area, turns out, are not that unusual. Basically, people have been feeling them. Obviously, the indigenous people that lived here before colonization felt them, and we have records of them up to 1774. In fact, in 1875, there was an earthquake that caused damage. We didn't have seismometers then, but we can estimate that the magnitude of that was around a magnitude 4.8. So this magnitude 5.8 was the largest historical earthquake in Virginia. Oh, let me fast forward this one here. There we go. So the map that I'm showing here that has the blue and then the area of brighter colors, this is a shaking intensity map. So this is different than the magnitude, but related to the magnitude in some way. So shaking intensity tells you how hard the ground shook in different locations. So the areas that are in yellow and orange shook severely or strongly in this earthquake. And you can see the rest of the area that's blue. These are areas that felt weak or light shaking. So you could still definitely feel the earthquake if you were in these blue areas. Now, this is an interesting map because this shows you the population that was exposed to different levels of earthquake shaking. So if you look in these gray, darker areas, these are areas that have a higher population density. So the area where the earthquake occurred was not that densely populated, but it was felt all across areas that were densely populated, like Richmond, Virginia, and Washington, D.C. In fact, this was the earthquake that was most widely felt in US history. Even though it was a relatively small earthquake, if we're talking about California or Alaska, places like that, magnitude 5.8 is not that large, but for the East Coast, that's pretty darn big. And all of these different colors are showing places that experienced shaking from the earthquake. Now, why is that? Why would this be felt so much more broadly than, say, an earthquake of the same magnitude in California? It's because the seismic waves move or propagate through the North American craton really well. So the North American craton is shown up here in brown, and this is the really old part of North America. So these rocks are dense and cold, and the waves just travel through them really well. So they can be felt over a really wide area. Some people say as much as 10 times more broadly than earthquakes on the West Coast. So, what fault did this happen on? We don't actually know. It happened in something called the Central Virginia Seismic Zone, which has produced small and moderate earthquakes that are felt, one or two are felt a year. And we know that it was a reverse fault, but we don't know exactly what fault it occurred on because we don't have a lot of good imaging in this area. We did have the US array, transportable array, that came through and gave us a great 3D view underground. But we don't have so many earthquakes that we know the faults as well as we do in places like California. So it happened on a reverse fault, like I said, which is where one block of rock gets pushed up and over top of another block right here. So how can we know that if we don't know where the fault is, right? We know because of the first arriving P waves at seismometers. So the direction that they're moving tells us the direction that the fault moved deep underground. That's called a focal mechanism. So we know that it happened as the result of compressive forces. Here's some more information. I'm going to switch over. Let me see if I can stop sharing this screen and then show you a different screen. Hold on. So I want to show you this cool thing. This is called a ground motion visualization, and this is going to show you how, let me share screen again. This is going to show you how the ground was moving in when the waves traveled through it. So here's the epicenter of the earthquake. Each one of these white dots is a seismic station. The one that's circled in yellow is the one that's going to be showing us this seismic recording along the bottom. When the dots turn red, they're moving up. When the dots turn blue, they're moving down. So the earthquake happens, and now you can see the waves traveling out from that earthquake and traveling across the US. Now, this isn't real time. This is sped up so that it doesn't take forever, right? The waves travel at about the P waves, the fastest waves travel at about 6 kilometers per second. So they're fast, but they're not this fast. Now, this shows us tons of really interesting stuff. So we'll watch it again. You see the waves travel out. There's the P waves traveling across. And certain areas shake more and for longer than other areas. See down here in Texas and Louisiana, it's still shaking, right? Even though these areas up here are not shaking as hard. That's because of the soft sand and soil that are in these regions. And that's shaking basically like a bowl full of jello. So places that have soft sand and soil will shake harder and for a longer period of time. So I hope that clears up some or gives you more information about the Virginia earthquake. It was a really interesting earthquake. It did do some damage around the capital, but it did teach us a lot about earthquakes on the East Coast. So 10-year anniversary today. Woo, Virginia earthquake. All right. Thanks, everybody.